Hi everyone, because we won't have time to go over the quiz, so I do it here. Hopefully you can watch this before the test. So the question is all about 5.5, which is satellites orbiting a star or a moon. In this case, you're given a moon, you know the radius and also the mass of the moon you can find out on the formula sheet. This is the height. So the orbiting radius is added the radius of the moon and the altitude. You should get 4.04 multiply 10 to the power of 6 meter. So you always start with the question, if you really need to do the free body diagram, uh, right here, free body diagram, you really should just get one force Fg. So and this force should be the centripetal force, which equals ma. A is v squared over r. Or you can replace the v with 2 pi r over the period t, which in this question you should, because the question asking for the period. Okay, and then this up to your math skill to simplify, cancel the m, and then put these things together and then just plug in. Be careful, they're big numbers. And if you calculate, you should get this 23000 second. Okay, second question. It's in the space station, so you shouldn't consider another gravity force acting on it. So in this case, for example, the free body drawn here means this person is experiencing a normal force from the outer wall. And do you have a gravity like going down this way? No. Okay, don't do that, because actually the gravity is in the direction perpendicular to the paper. Okay, so it won't affect this direction. Okay, so if you got that Fn, so you can find it out equal, because that's the only force to be the centripetal force, equals mv squared over r. Again, change the v into 2 pi r over 2 pi uh, 2 pi r over the period t. So plugging everything, you should get 767.64 Newton for a 60 kilogram person, right? And then to find out the ratio, you just take this force divided by the Fg, which is on the Earth. But I don't know what happened to these two excellent students, Jeffrey and Sheldon. They got this. Uh, oh. Oh, actually, this is. I think this is not wrong. I made a mistake. Yeah, I think they're right. Because they changed this to 1, and yeah, actually the ratio, if you divide by to get a number, you should get 1.1, right? 1.1 something. Okay, sorry, I give you mark backs, so you should get a 10 out of 10. Okay. Oh, and one last thing about this question. So if the space station rotated slower than the period of the rotation, and then so that is the period increased. So when you rotate slower, and you should have less centripetal acceleration, which means you need less centripetal force. In this case, is the Fn. So when the Fn reduced, as a result, the astronauts just feel like, oh, there's less pressure pushing on my feet. So basically, he feels himself becomes lighter, or the experience less artificial gravity. Okay.